Thanks. Afternoon, folks. This time around, I'm taking you through assembly language and bit manipulation. Things that we're going to concentrate on are assembly language and bit manipulation. So in this series, we are going to be interested in explanations as to what's the relationship between assembly and machine code. We're also going to look at two-pass assembly process, then assembly language instructions, addressing modes, dry run assembly language so that we can come up with machine code. Also perform and explain bit shifts. We are going to use bit manipulation to check register values. So the terms that we're going to find interesting in this discussion are terms such as machine code, assembly language, mnemonic, opcode, operand, two-pass assembler, as addressing mode, logical shift, arithmetic shift. All those things are going to be dealt with in detail. We also have bit masking. Now, assembly language, the relationship between these two. With a machine code, this consists of binary instructions, which are set of zeros and ones, and these are directly executed by the CPU. Then we also have assembly language, which uses mnemonics, which are human readable, and these uses terms such as load, branch, in, out, you name them. So each assembly instruction usually maps to one machine code instruction. Now we have got the two-pass assembly process where we've got step one, where we read assembly codes, identify labels, and store their memory addresses. Then in this process or pass, there's no machine code that is produced. But then in the second pass, we have conversion of mnemonics into opcodes. We also replace labels with actual memory addresses. Then we generate final machine code. So when we are moving from assembly to machine code, it involves these two passes. Then when we categorize assembly language instruction, if you want to move data, we've got instructions such as move, load, store. When arithmetic is involved, here we are looking at computations such as add, subtract, and or, and then comparison, the CMP, control flow, as in if else, we've got jump and branch. Then if we're inputting or displaying data, we have in and out there. Then when we are looking at addressing modes, the mode is such that when we say direct, this refers to direct uh, memory location and register. That's the operand stored in a register. Indirect address gives location of another address. Then dry running assembly code. When we dry run, it means we manually tracing instructions step by step to determine register memory values. Then we are looking at bit manipulation, which are two logical shift left. Then we also have logical shift right. With logical shift left here, because values will be going to the left side, it involves doubling the value. So here we shift this to the left, zeros fill from the right, then equivalent to multiplying by 2. Then logical shift right, here we are doing a similar process but in reverse. We shift bits to the right, then zeros fill the left part, then this is equivalent to division by 2. So what's the effect of shifts? If we are shifting to the left, then the number increases. We shift to the right, it's like it decreases because we'll be dividing by 2. Now, bits shifted are actually lost. Then think with that information, we can talk of bit masking where we use AND or XOR. We want to check if a specific bit is set. Then I'm going to take you through the following 10 examples with the discussion that we did earlier. Thank you.